Hello, my name is Akshay, and this is our project V2V Communication, where COM stands for Caution, Observe, and Mitigate. As you can see from the screen, we have emphasized on vehicle to vehicle communication, and the wireless technology that we have used is LoRa, which stands for long range. Now, let me explain the project further. So, let me give you a high level understanding of our project. So as you can see, this is our setup. Here you can see two Arduinos interfaced with LoRa transceivers, but in reality we have used three Arduinos, and let me explain it further. The first Arduino is integrated with the sensors, and the sensors output can be seen on the screen. The sensors that we have used are the accelerometer, yeah, here, the GPS module, and the ultrasonic. The GPS module here is the Neo 6M, and the ultrasonic is HC SR04, and that was our accelerometer. As you can see, if you bring anything further in front of the ultrasonic, we have made sure that an LED glows, and shaking the accelerometer glows another LED, which will be explaining it further. As you can see, the the data from the sensors is shown here on the screen, and regarding the displaying part, we have used ThinkSpeak as the IoT analytics platform, which will be storing our data, which is our GPS data from both the transceivers in real time, and we can see the different graphs that it creates. This is our second transceiver, which has the same sensors as seen before, and this is supposed to go on another vehicle, and it works on a battery, so the module is completely portable. The best part about ThinkSpeak is it provides us with an application which is useful to view the same data on mobile phones as well. And now Rakesh will be explaining further the the working of the same.
So as you can see over here, now the cars are acting autonomously. So this is a car which acts autonomously. It has an Arduino that has been mounted onto this as a car, where you have an LoRa module, you have an accelerometer, you have a GPS sensor, and all this data would be broadcasted. So as you can see, even this car has the same set of components with an ultrasonic that is being over here, and the data that is transmitted from the other car would be received by this car and processed, and similarly this car would also be transmitting. So in extension, what we have done is rather we have to. I mean, the cars are exchanging data between themselves, but how is it possible for us to visualize it? So for that, we are using another LoRa equipment which is connected to the Arduino board, which shares the data with the internet. I mean, which sends the data to the internet by receiving the data that is being transmitted by both the cars. So this data that is the Arduino is receiving over here is being transmitted I mean, is being displayed in real time, as well as you can also see it in an app. So as you can see on the phone over here, you can also view it on your phones, as well as all the data that is being received is in real time. So now let's look at the demonstration of this. So to start with the demonstration, let's put the cars on the road and start moving them. So let's look at how the vehicles perform in the real time. So as you can see, we'll be starting off with vehicles close by, and as the vehicles are close by, the ultrasonic sensor is detecting a vehicle in front of it, and that is too close, and that is a warning to the driver, and that warning is detected is shown to the driver using a red light. You can see a LED being blown over here. So And we are right now dealing with two scenarios, where the first scenario is the vehicles being too close and the ultrasonic sensor would detect the vehicles being close, and that is how that is an alert to the driver using a red LED. The second scenario would be if the vehicle in front of it or the vehicle ahead of the vehicle behind is decelerating or stopped, and the vehicle behind is accelerating. In that scenario, you would have, you should the driver should be alerted, and that is shown using a green LED. Now let's see the scenario where the vehicle would be moved forward, and you can see the ultrasonic sensor turning off. So as you can see, the ultrasonic sensor is turned off, as well as the is not detecting a vehicle in front of it, and that is the reason the red LED is turned off. And now let's look at the green LED. So the vehicle behind is being accelerated at a higher pace than the vehicle in front of it, and that is the reason the green LED is turning off. And once the vehicle is stopping, the green LED is turning off. That is the reason. That is because the acceleration of the vehicle behind is higher, and that needs to be alerted to the driver. As you can see, as the vehicles were being moved, the data was being recorded every 5 milliseconds onto the LoRa equipment over here. It was being transmitted by the body cars, and the LoRa equipment over here, uh, which is connected to the Arduino Uno board, has been receiving the data, and this data via a serial port is being communicated to the internet, where it is being reflected on our ThinkSpeak. As you can see the data over here, we have all the real world data that has been come, and as you can see the timestamp over here, it's 2124, which is the most recent data that has been received, as well as over here, and this is the location where the vehicles were moving. And as both the vehicles are in the same GPS coordinate, the GPS coordinate is being displayed over here, which is in Buffalo. And this is the gauge meter that was being displayed. This was the last data that was received, and the vehicle was moving at 9 speed. Uh, and this is how we would be able to display our this is how a user can evaluate his performance in the real world scenarios. And this is how all vehicle to vehicle communication has been established and a network has been created. And this way you have many advantages, where you can alert the driver, caution the driver, and you can also you can get rid of the obstacles where the visibility is low. And this is how successfully we have established a communication between the vehicles, as well as the data being exchanged to the centralized unit where it can be processed in future. So now looking back at all the scenarios that we displayed, at this the scenarios that we displayed would justify the statement of caution, observe, and mitigate. So as we say caution, we are cautioning the driver when the vehicle behind is accelerating at a higher pace, and we are helping the driver observe his performance, and we are helping the driver to mitigate. I mean, this would in turn enable the driver or the vehicles by mitigating the accidents. So now let's further take into the scenarios, the real world scenarios. If the conditions, if the visibility is low, this vehicle to vehicle communication would be really helpful in establishing a communication between the two vehicles. In alerting both the vehicles regarding the presence of the other vehicle, and this way you can alert the drivers as well as mitigate the accidents. And this use cases could be further improved by having further a lot more number of use cases in terms of parallel routes, in terms of junctions, where two vehicles are closing into the junction and the vehicles can communicate, and this is how you can further improve the reliability of the system. And in future, this could also be used by the autonomous cars autonomous cars driving themselves. So this was our project, and we would like to hear some questions from you. Thank you.